Hi, everybody. Welcome again to this webinar on saving big on returnable packaging using the Internet of Things. Thank you for taking the time off to attend. Just before we begin, I wanted to give you all a quick introduction on the reason why we chose this topic and also about our host, Vidya Subramanian. The reason why we had picked this topic for this month was because a lot of supply chain managers in our networks who have been working with us, either customers or prospects, have been exploring the potential of improving their bottom lines in their supply chain by managing their returnable packaging better. Also, with the advent of the e-commerceization of the shipping space in general, there has been a lot more use of pallets, especially the smaller types and other returnable packaging, which could potentially be optimized better to enable you to run a more cost-effective supply chain. Um, our speaker today is Vidya Subramanian. Vidya is well accomplished when it comes to solution delivery. Being an engineer, he has held leadership positions not only at startups, where he's built a few startups. He's built a startup called Ketone, which was essentially an RFID solutions company. He's also held leadership positions in companies like KPMG, Plexus Technologies, and many more, which means he comes with an experience in not only designing and deploying solutions for the industry in general, but he's also been on the industry side where he has worked with a variety of solutions as a customer. So I'm passing the screen on to Vidya to take it forward from here. Thank you once again for joining, and hope you have an enjoyable session. Thank you. Vidya, please take it forward.
Thank you, everybody, for joining us this morning to discuss returnable packaging and its visibility and its impact within the larger supply chain, if you will. As we get started in terms of talking about returnable packaging and its life within the supply chain ecosystem, we'd like to run a short poll to better understand how many people work within returnable packaging. We've had situations where people, after learning about what we can do within returnable packaging, have started moving towards returnable packaging. So can we have a short poll right now? And the question is fairly simple. Are you currently tracking your reusable shipping assets? And these could be everything from shipping totes to monotainers to envirotainers, and the lot. So it's a good mix where we see about 30% of people currently using this and 70% not so much, which allows me to then start on talking through not just our experience with returnable containers, but putting a flavor of our customers and how they perceive the future use of these containers. Let me start off by kind of talking a little bit about what constitutes a returnable shipping asset. We're all very familiar with pallets. It's most common that we see moving within the supply chain. But there's also some very specialized movable containers. And these could be around the automotive industry. This could be around the produce industry. This could be around waste management. And heavy lift containers, which could be project-based in the oil and gas industry. And one of the reasons why we focused on returnable shipping assets was a couple of areas. One is it definitely makes sense to reuse. There's a lot of value in going green, but there's also a lot of value in having specialized containers that then get into a closed loop ecosystem, if you will, which are very traceable. One of the things that we're working very closely with industry is even the common pallet to make it reusable, not just in terms of the ability to save some of the remanufacturing costs, but the ability to have some traceability, if you will, within the containers. There's also a very large e-commerce effect on returnable containers. As we're noticing the supply chain change, we're noticing a lot more just-in-time deliveries, a lot more specialized deliveries, which means that a container could contain more than just one type of product. So typically, we're used to supply chain where we're sending batches of product, be it produce, be it automotive parts. So, for example, you could have, General Motors or Ford Motor Company send, chassis or send transmissions all in specialized containers, and they're one type of product, and the container is meant for that one type of product, and it moves around. But we're also seeing a lot of specialty deliveries within the North American market, within the Asian markets, where we have food delivery services that could potentially be delivered either through a distributor to an end retail channel or to the end consumer, if you will. So we're going to work with a variety of packages, which include small packages, totes, and large multi-use pallets, if you will. What are some of the areas of use, if you will? And some of these would have been non-intuitive. We're mostly used to some of the common moves, which are palletized loads. People might refer to them as less than truckload. And the industries that use them were around manufacturing, high tech, and F&B, which is food and beverage. But we're also seeing that there's a lot of specialized closed loop movement happening within the automotive sector, happening within the retail sector to stock probably forward locations. We're also seeing a lot of interest coming from healthcare, where we're seeing pill prescriptions being fulfilled. We're seeing clinical trials being managed in returnable containers. And all of these tend to be more suitable for closed loop. So we're looking to understand, for example, in an automotive sector, like I talked before, the ability to have new parts being delivered to an assembly plant, and then the empty container that delivered it being returned. And what this does in a scenario like that is provides the ability, if you will, to not only know how much inventory is moving, but the ability then to understand its movement nature, if you will, the areas where it's retained, areas where it's stocked, areas where it's moved. And I'll talk a little bit more about that in actual use cases, because it just makes it more contextual in what we're doing. Having talked about containers and having talked about some of the people that typically use it, I get asked this question all the time. If money were no option, why would I want this back? It's more than economics. And that's really where I want to try and sort of walk through scenarios where we realize that it's actually not the cost of packing. It's not the cost of a returnable asset. It's the value of not having that asset, or having too many of those assets in your supply chain environment, both of which lead to probably what is non-intuitive causal effects of being able to store them, to return them, to dispose of them, and all three of that. So just some numbers that would resonate. So about 10 to 40% of returnable assets are typically lost. And I want to kind of highlight the word lost. People are not stealing these things. This is within a pretty controlled supply chain. Now, there might be some, some loss due to theft or mishandling, but the reality is they go into environments where they're not visible to the folks in the supply chain that use this. 10 to 20% of budgets for logistics and supply chain are actually spent replacing some of these units. And just to give some folks some thought process on RSAs, they could be anywhere from a pallet that costs $5 to $10 to specialized totes that can cost 20 to 30 to specialized containers that could cost $100 to $200. Still, if you look at the magnitude of this, we're not looking at a supercritical container cost that would lead to it being in a very controlled environment, but we're looking at volume that would lead to the price point. I want to talk a little bit now about the causal effect. Typically, because we can't find these things, and we don't necessarily track them through our entire supply chain. For example, one of the most common examples are food and beverage delivery. The two big brand names across the world, Coca-Cola and Pepsi, deliver a lot of product to distribution centers, which then could go to a multitude of retailers, which then could go to forward delivery locations. So for example, if Coca-Cola is delivering its pallets from a warehouse to a variety of retailers in the North American market, it could be somebody like Safeway stores, it could be somebody like Meyer Pharmacy and Grocery, or in the European theater, it could be Carrefour, if you will, in that capacity, or Metro stores in Europe and in the Asian market. Now, Coca-Cola doesn't know who's receiving those pallets, and it's very, very difficult for them to get them back. So in consequence, they build overcapacity to manage this delivery. Why does this all matter? Is something that we should all ask ourselves. And there's some very, very logical things that happen when we either have too many containers or not as many, less than optimal. One very critical piece is the production capacity. In a lot of these environments, such as pharmacy, such as automotive, food and beverage, produce, a lot of these containers are filled in the production lines or packed in production lines. And the inavailability, if you will, of them will lead to very direct consequences of changes in production capacity. And as systems get into full automation, if you will, the inavailability of any one of these can have serious, very direct impacts on bottom line. Automation, especially in the automotive industry and some of the food and produce industries, the lines are getting very automated. We hear about just-in-time manufacturing. We hear about first in, first out, which means that not just do I have to have my product available at a certain time, I need to have it available in a certain order, which means that the containers that they come in have to be managed and tracked through the entire process. Having too many of the containers in an environment, a lot of us have noticed, but probably not paid attention to the amount of pallets that just lie around, probably behind stores, behind distribution centers, and especially around ports. It's because when product is consumed, the pallet is just assumed to be a natural consequence of a packing material that needs to be disposed. And when you look at the magnitude at a global scale, it's pretty large. Some of the customers we work with rotate about 500,000 to 750,000 pallets a month. And that's a pretty large number, if you will, to then add to being able to control where it ends up and being able to bring it back for reuse. One point to note, when dealing with thousands of pallets, a very small percentage loss is a pretty large number, both in terms of the cost of the returnable asset, but also in terms of the human touch, if you will, that goes to manage this. We repeatedly hear from our customers in large warehouses where they have two or three problems with tracking these containers. One is a first in, first out problem, which especially in produce, we really need to manage the workflow where we want to control the aging of product. So the oldest product leaves first, which means that you need to know which container that product is in to be able to control that. The other one that we deal with a lot of times is just pure inventory. If we had smart containers, what we hear that visibility could be dramatically increased. Some best practices on a slight segue from what I'm going to continue to talk about is some of the rules of engagement, if you will. One simple thing that I smile and tell a lot of people is don't lose sight of your pallets. Assume they're important enough where if you knew where everything was, it could be a very, very interesting world where now you not only know how your product gets from your manufacturing or your distribution center to the people that consume it, but you also know how efficient you are in managing the entire ecosystem. The other thing I tell people is don't just buy more because you can. A lot of companies just assume that they can have a 25-30% overstock capability because that would then help them reduce any production delays. There's a fear that even with automation, with visibility, that the control mechanisms might not be there to drive to a very, very low par level. The kind of buzzword we use are par levels. So typically for every 4 to 5 reusable units, people keep a par level of 1, which is an extra unit, which is 20%, if you will, of the total volume. The other piece is to have them available when you need them. This could take a lot of space, depending on the type of container and the rotation capability. Some companies have a drop-off pickup policy on returnable containers. So the delivery organization, if you will, is tasked with bringing back the containers that have been used. Very common in automotive, very common in pharmaceutical, and very common in the cold chain, because these tend to be special containers. Not so very common in pallet loads or less than truckloads that deem the pallet disposable. One of the key things that I would like to have as a takeaway in this is that you need visibility across your ecosystem. A lot of companies have barcodes and have technologies that allow them to have a very tight inventory control mechanism when it's in their control. But the story I talked about where Coca-Cola is delivering to a warehouse, is delivering to a grocery store, the moment it leaves a Coca-Cola warehouse, they have complete lack of visibility on where it ends up. So a Coca-Cola pallet could end up with Pepsi. Good for Pepsi in that situation. But one of the things that we're realizing in the larger ecosystem is it's not a competitive advantage to really keep track of returnable containers. It's an ecosystem advantage, which means everybody benefits. It's not like a company doing it will benefit over company B, but all companies doing it will then produce a much larger, efficient supply chain system, if you will. Let me go into something that is more visually appealing. And this is a use case that we see come up a lot, which is pallets that go within a closed loop delivery mechanism. So manufacturing to distribution to retail, and distribution to retail might not be full palletized loads. They could be mixed product being delivered to the distribution centers. So for example, Coca-Cola has 7 or 8 beverage products. And so in a distribution type to retail, you might have 2 loads of Coke, some loads of Mountain Dew, and a few other different types of beverages. And at that point in time, it might go on a different pallet. So if I'm looking at a pallet cycle in an ecosystem, one big advantage of monitoring its life cycle in real time, which could be in 2 phases. It could be in every location where it's stored. And the second, which is progressive, is even while it's in transit. So you have the ability then to monitor things in real time. You have the ability to understand the movement process. So very, typical of a Kanban, where it comes from inventory to manufacturing pre-pack to storage for ship to retail, and the whole process through and through. And through that, you're looking at where all it lives, either with or without product. And if it's with product, now you're talking of capital inventory that's sitting, waiting to be sold. So that also has an impact on the larger supply chain. The other piece that you're looking through is the ability to monitor these without infrastructure. And we'll talk about some of the emerging technologies that are making this easier. We tried doing this in several different ways about 15 years ago, using a variety of different technologies available at that time, RFID being one of them. And now we've seen the technology evolve by addressing all the pieces that were important at that time to the people that were deploying these technologies. So we'll talk a little bit about the technologies that come to play, and about the impact on in-transit visibility, talking about utilization and movement while in transit. And if you look at the products between warehouse to end retailer, manufacturing to warehouse, is almost 10 to 15% of its life cycle is in transit. And that's transit between locations. And if you look at movement within some of these warehouses, that can add another 10 to 15%. So there's a lot of touch involved in some of these products. How does this all play out? And here are some visuals that give you a better understanding of the type of product, the type of material. In the past, there was a lot of use of RFID technologies, which then folks understood had a lot of difficulty because of the technology and physics with liquids, with metals, things of that nature. And as technologies and processes have evolved, this has changed to adopt to technologies that are more resilient for them, built to last in the open environment. So, heat, dust, moisture, that sort of thing. So what you're seeing here is an example with Bluetooth technologies. And a lot of you might be very, very familiar with Bluetooth because we use it subconsciously every day, either to plug our headphones into our smartphones, or to have wireless speakers in the house, or to talk to equipment in our automobiles. So Bluetooth is becoming very pervasive as a technology, and it's one of the many options, if you will, in being able to have full visibility. Having said, and set a context to what it means to have returnable assets, what are these assets comprised about, who uses them, I want to talk a little bit about why we are thinking of new technologies today when a myriad of technologies have existed for decades that have been used in some context or the other. We've heard of smart containers, we've heard of smart logistics, and I want to talk about some of the challenges that some of the folks, the 33% of the people that answer the poll said they use reusable containers. Maybe you've not looked at some of these technologies because some pilots did not work. One key piece that I hear all the time is economics. We need to have visibility come almost at a price point where you don't consider it to have impact on your larger supply chain, if you will. If this means an economic impact at the unit level or at the program level, it will have an impact to what you're doing. The second thing is it's not just about the traceable entity, what you put on a pallet or a tote. It's about the infrastructure that's available to be able to identify that specific container and be able to manage that information. So in the past, when you looked at technologies like RFID, you needed to have physically installed infrastructure or mobile infrastructure that was expensive, but also proprietary. So the example I'll give you is we've had customers that had very controlled closed loop environments from their manufacturing facility to their warehouses, and they employed RFID, and it worked very well because it was their environment and very controlled. Now, as they started shipping the same smart pallets to their partner ecosystem, either in value-added manufacturing or retail, they realized they were losing all the visibility because their downstream partners were not incentivized or were not ready or capable to deploy the same infrastructure that these companies had deployed within their environments. And the economics was important because just the deployed infrastructure could run anywhere from $100 to $500,000 US dollars, depending on the environment. And now you scale that across multiple warehouses, and it becomes very expensive. The other big reason, other than economics, was the ability of physics. All of these technologies, in some form or the other, use radio waves to communicate. And that radio technology tended to be very, very focused on the environment that it was built for. So you had environments that were highly metallic, and they developed certain technologies for that. There were some that were highly susceptible to liquid, beverage movement, vaccines, things of that nature. So technology was a challenge. And when things moved out of your controlled environment, it was a challenge. I talked about infrastructure availability, but it also means information availability. So for example, if I used to ship something from North America into the Asian market, even with RFID or any other radio technologies in the past, the two countries used very different standards for the radio disturbance that was there. So a North American shipper couldn't really ship into China and make it work seamlessly. And these things become important when you scale, when your numbers are beyond the thousands, when they're hard to manage in the millions, if you will. So what does that mean to where the technology has come from? These are some of the examples of the technologies that we work with. They're focused on a variety of communication capabilities. We work with the cellular network, so you have GSM, LTE networks. We work very closely with Bluetooth-based networks, so they can come in a variety of different form factors, of different ranges, and of different power consumption capabilities to last the product. But one of the key takeaways here is to then use technologies that are not proprietary. So Bluetooth, for example, is a technology that is very, very close to what we're very familiar with, which are Wi-Fi networks, which have a standard across the world. So Bluetooth in China is going to be the same as Bluetooth in the US as it would be in Brazil. This makes it very, very easy to deploy globally. Now, same thing with cellular technologies. Other than your 2G, 3G, and a few bandwidth constraints, they're pretty common across the world. So GSM, for example, as a technology, can be deployed across the world in this capacity. So we're coming with new technologies that can last very, very long. 5-7 years is now getting to be very common in the ask, which means that it can last the life cycle of the asset, if you will, in the capacity. What do these technologies do for us? They do two things. And this is where we're seeing a lot of the future vision. We're seeing data being collected across its entire life cycle, which means indoors, outdoors, and in transit. We're also looking to have a lot of customers track this at the unit level. So in the past, we used to say a unit was a pallet. Now we're saying a unit is a tote. And that's a pretty dramatic leap of faith, because you're talking from a 1 to 100 increase in scale of use. What I mean by that is, a typical pallet might have had 60, 70 cases on it. Now they want to track every case as a tote. So that puts a lot of pressure on the technology and on the ability to scale that information, if you will. The other big piece is a global deployment. So a lot of our customers now are pretty pretty global in their deployment footprint, even though they might have localized processes and or environments. Their strategy is very global. So examples would be large automotive manufacturers, Toyota, Honda, Volkswagen, Daimler. They might have 20, 30 manufacturing facilities across the globe, but they would really like to have a single strategy that gives them economies of scale, if you will. Having leveraged item level and global capability, real-time visibility then allows you a lot more control. We've asked ourselves so many times, I wish I knew where it was, because if I did, I could do something about it. What does that really drive to? It's actionable change. So if I can tell you where something is, you can take action. But lack of information would lead you to build processes of what we call redundancy, which then become overheads over time. And it all leads to a simple aspect of I wish I knew. And that capability is coming now at a price point where it's truly something that people can look to adopt, look to understand better, and then build into their innovation paths, if you will. One thing that's very interesting with the mobile phone that is in a sense good, but in a sense very useful in the B2B enterprise. I think everybody now has pretty much heard about Facebook and what they did with information. But a little nugget inside there is the thought process of the ability to collect that information. Now, on the social side, you can do some interesting things as Facebook did and regretted. But on the enterprise side, this becomes a very, very useful capability. And the usefulness comes in the distributed nature, if you will, of the business. So for example, if Mercedes or Volkswagen is getting parts made from mainland China, Brazil, and the US, they can now have inventory managed in China, Brazil, and US without having to have any special infrastructure shipped to these locations, because someone in that environment could potentially download an application made by the company and then do their inventory for them. And why were they able to do that? It was because of something like a Bluetooth technology that is globally available. This also then springs to completely scalable solutions. So if I didn't have to send you infrastructure for you to have visibility, and I could turn this on by having you download an application of something we're so familiar with, the App Store, and then you being able to do inventory, changes the dynamics of how we can operationalize this in pretty much any environment with very little impact to current process. What I want to do is talk through the entire ecosystem. And now I'll talk a little bit about Roambee as a company and why we came about doing what we did. And through some of my past experiences, which focused a lot on visibility within the four walls, visibility within, I'd say, the larger ecosystem of the globe. And Roambee came about as a company that's focused on putting emerging technologies into play with current economic models. What I mean by that is the ability to have somebody adopt these technologies without large infrastructure spend. What does that mean? It means a unique approach to IoT adoption. IoT has been, sort of the word everybody wants to understand, grab, say they're working with, and it's actually not that complex. I break down IoT personally into the ability to have information come from pretty much any source that can then help us manage that source better and manage the touch points of that source across the ecosystem. And there are three big things to this. One is, what does it cost? Not just to purchase, but to use. We're so in a world where we purchase, and it's really moving towards now where you use on demand. So a very good example is Amazon with its Prime membership. What they said was, if I can tell you there's an easy way to get something to you in 2 days, you don't have to buy something every day, but whenever you went to buy something, you knew it was going to come to you in 2 days. It'll change the way you think about and you plan your purchases. And it changed the dynamics. So economics and the spend capability when you need it or when you want it becomes important. Operationally, this needs to be deployable without having large human touch or a process change. So that ties very much with a service-driven capability. An example here is we've got situations where people design products. A very good example of this would be Apple. Apple designs products. Foxconn manufactures those for them. Maersk and Siva and DB Schenker move it for them across the world, and you've got retailers from Apple stores to Best Buys to Carrefours that sell it. Apple outsources everything, but Apple is responsible for the movement and the ability to manage its entire inventory. And so then having a service-driven operational deployment becomes very important. They'd like to say to someone, hey, can you make sure that when this product leaves China and it reaches the US, that it's trackable? So someone needs to work with those entities. And that's a service-driven model to adoption. Who are some of the people playing in these technologies? I wanted to put this up here to have people look at it to see the diversity of IoT adoption with returnable containers. We've got automotive companies, we've got logistics companies, we've got courier companies. And to a courier company, actually, a returnable container could be a bag full of small parcel packages going to a forward location, or it could be airline containers that contain multiple small packages going to a forward airport location for further distribution. And it could be, everybody from a Porsche to a pharmaceutical company. And all this happens with a lot of synergy with infrastructure companies, because they provide, if you will, the SLA backbone. So it could be phone companies such as Deutsche Telekom or Telus Networks out of Canada. But the ecosystem now is big enough and it's ready for adoption through a variety of ways. And a lot of people have already set a very good example. So we don't have to be first movers anymore. We could be adopters, not of the bleeding chain, if you will, but of something that's been deployed and proven correctly within a global environment. I wanted to end on that note where adoption is happening. There are multitude of case studies across a multitude of industries that would help then educate people on the different ways we can use this technology to be able to not only streamline a supply chain, but also add a lot of, I'd say, bottom line savings across the entire manufacturing, distribution, and retail processes. I want to thank everybody for your time and the attention today. If there are any questions, my email is on the screen. Feel free to reach out to me directly, and I will be happy to talk about possible solutions or just experience based on the topic we discussed just now. Thank you very much.
Thank you, Vidya. So we have some questions. Some of the questions were sent to us ahead of time, and some are being asked now. So I'm going ahead with some of the questions that were asked to us when some of our guests signed up. So one of the questions is, tell me something about the demonstrated improvements in the loss rate.
That's a very good question. One of the ways to quantify loss rate is to look at the amount of sort of containers that we actually know their location and their state. So what I mean by that is if I actually know where my inventory is, then I will be able to understand what my shrink rates would be. But imagine a lot of these are not really lost, they're just not available for consumption, which means I sent it to a retailer and they stocked it in their back room and they just keep it there because they think that every 6 months they'll send it back. So the ability to control loss rate also drives to the ability to know where things are. And I think I touched upon this. A lot of loss is not malicious. It's about visibility. And because the supply chain is getting so diverse, these containers end up in areas where they're not directly visible or intuitive for pickup. And on that note, one thing that we just do operationally, or we talk to our customers operationally, is even if you don't have smart containers, if you have a drop-off pickup process that you can deploy, then you can actually have a big reduction in your loss just by that, because there's a constant process where people know that there's something to pick up, and it's pretty cyclic. If I drop 10 and I don't have 10 to pick up, then you could automatically start flagging those things.
Thank you, Vidya. The next question is, how scalable is a BLE-based solution beyond RFID, manual debit and credit tracking, or barcode scanning, especially when you're talking about at least hundreds of thousands of assets?
It's a very, very good question. We always get asked about the technology and the saturation levels, if you will, within the technology. And one of the things to understand is a lot of the tests initially were done with saying how many of these smart tags, if you will, can I read in a particular area. What we realize with industry is it's not the density per square meter that you're worried about, but it's the distributed capability of being able to manage that large number of assets. So for example, when you have 4,000 to 5,000 assets in a particular room, the technology will not have a problem reading it. When you have it distributed across the globe and you have 1 million pallets, then you have many different points of data collection. The important aspect there is not so much at the edge, which is the tag, but it's really the platform. It's really the application and the environment in which one looks at the ecosystem and says, if I have 1 million tags talking to me at one point in time, am I able to listen to all 1 million of them and be able to respond effectively? So what we've looked at this particular aspect of scale and density is in two aspects. One is at the edge, where we can read a certain dense population, 5,000, 10,000, to a scalable environment where we can read 1 million to 10 million to 20 million at any point in time. So it's a combination of the edge and the platform and the infrastructure for information management.
Thank you, Vidya. There's a lot of questions actually that's coming up. But with the same question that you answered, there was also a note about the cost that goes into going at the scale that you were talking about.
And economics is a very good question. One of the things we look at when we're costing this is the ability to to cost a individual smart tag. So in the RFID days, there was always this talk of saying for global implementation, an inflection point of tag cost would be 1 cent, 1 US cent. And the cost could never come to 1 cent. But what the industry became aware of is the ability to look at it not as a one-time use, but as a multi-use capability. So imagine now with smart tags, say I'll take Bluetooth as an example, we can look at an infrastructure cost of a tag between, say, $3 to $5, depending on the type of environment. Now, one would think that I'm deploying that per asset and then multiply that by 1,000,000 and say, wow, it's going to cost me X number of dollars to do this. But the reality is we look at a loss rate. So if I'm losing 20% of that, and the cost of the pallet, I might be losing, $5 to $10 million because I can't find something. But with the reuse capability, imagine now that $5 is over 5 years and 60 months. Now you're looking at a price point that's almost the same as RFID, which is less than a nickel per unit per month. So what we look at when we tell our customers about the economics is look at it from a period of time of use and the number of times you'll use it between that period and how that then translates to an individual cost. So typical solutions to us are 2 to 3 year life cycle. So you're looking at 36 months, and then when we divide those costs into a single unit, you realize that that whole idea of reusable containers becomes very, very plausible and very attractive.
The next question, Vidya, is around the sustainability angle of monitoring your returnable packaging.
It's something that one has to look at in their own environment. We're seeing the adoption grow significantly. We're seeing a lot of people ask the question, why can't I reuse? And the answer most people get is because once you send it out of your ecosystem, you don't have control over it, and thereby you can't reuse. Now, we're trying to change that paradigm by saying if you did know where it was and you did know where it was going, you can work with your entire partner ecosystem and have it come back. A very traditional way I explain this is, a lot of us are familiar with, the if lost, please return tag that you see on a lot of assets. Imagine that was actually being automatically done through a smart tag where it could tell you, hey, I'm actually lost in this environment, but I'm actually here. Can you bring me back? And so the sustainability of this is just growing and growing because now people realize that with visibility comes the opportunity of change. Without visibility, there was no ability to even know. So one of the things I encourage our customers to do is to try it. So the idea here is if there's no upfront capital expenditure, if there's no upfront process change, then the ability to understand your ecosystem becomes very important. So imagine it's like sending some, Star Trek sensors out to go sense a planet and tell you what's there. Inject these smart sensors into, 100 pallets, 500 pallets, and see where they end up. And the results would be dramatic because now you actually know where they go and where they live. And so you can now make decisions on the life cycle of how they go through.
Thank you, Vidya. So now there are some Roambee specific questions. I'm going to start with the first one. How long does it take to implement the Roambee solution when it comes to returnable shipping assets?
We've actually structured this to model two things. One is to really have people understand if the technology works in the environment that they'd like to deploy this in, and the second is, does the process work? We've kind of eliminated the economics. The economics will work. So in that capacity, we've had customers start to deploy this within weeks. And we've had customers start to scale this within weeks. So the time frame from a try and buy perspective could be as simplistic as days to a full understanding of the ecosystem within weeks. Now, there are some environments where the transit time or the total ecosystem is very large, but barring that, it's very, very rapid.
Okay. In certain areas where BLE frequency is blocked, how do we get around that?
So we have a variety of instances where we get asked that question. So BLE's frequency is around the Wi-Fi frequency, which is 2.4 gigahertz, which can interfere if there's some manufacturing environments where certain equipment is also using the same frequency. Typically, the way the technology is structured is it's not obtrusive, which means that it doesn't take ownership of the environment. In very specific cases, we've got technology within the smart tags that environmentally will turn themselves off for a period of time till they then are returned back on, which means that they're actually on, they're just not transmitting. A very similar situation happens when on an aircraft, if you will. For flight safety reasons, we identify that we are on an airplane and we turn off transmissions. So on a case-by-case basis, we have schemas that enable us to turn ourselves off and on as required by the environment.
The next question, Vidya, is around cluster logistics. So there is a need for load optimization on trucks where boxes are consolidated and loaded. Is this a use case that is supported by Roambee today with the visibility solutions that we have?
So Roambee today drives around visibility, and visibility extends across a couple of areas. One is an area what we might call a defined area, call it the back of a truck or a zone or a cage or something else of that sort, and the ability to then understand patterns across it. So for example, if we're loading 500 small packages into a 15-foot truck, we can understand the volume capacity of that, and then look to see for every trip how many are being put in to that truck. What Roambee does not do is work within the parameters of showing you how to load it, showing you the place capability within within that storage facility, be it a truck or a warehouse. But what we do provide you is the insight of the quantity and the periodicity of what we put in there. So in this situation, we would integrate with probably existing systems that they use for pack modalities and then provide the real-time inventory capability.
Thank you, Vidya. The last question we have is from a viewer in Mexico. Do you really recommend using a Bluetooth system when compared to RFID? I know you covered some of this, but in context of tracking materials and tools, and also what is the direct value that's added to the business in doing so, if this is possible?
So Bluetooth is one of many technologies available today. And just like RFID, there are form factors, there are different deployment capabilities, things of that nature. What Bluetooth does, which is kind of unique to itself, is the fact that it's a completely open standard, which means that if it's my environment, I can control it. If it goes into another ecosystem, I could potentially have it picked up through a crowdsourced environment. Now, talking specifically about RFID and Bluetooth within tool tracking, and we've done a lot of research into tool tracking with RFID and with other technologies. One, the size of tool definitely does matter. If we're looking at specialized spanners or other specialized tools, a form factor has a problem. But if we looked at a tool from a situation of an air compressor or something else of that nature, Bluetooth becomes a very, very viable option. One big proponent of Bluetooth is 100% read capability. It's not very intuitive to a lot of people. RFID struggles to be 100% unless it's in a very, very controlled environment, which means a typical check-in, check-out process for tools where people walk through a door with RFID readers becomes problematic because I can't guarantee 100%. But with a Bluetooth type environment, because the tag is active, the ability to see where it goes and monitor it at significantly larger ranges and accuracy capabilities makes it viable. Is it a one-size-fits-all? I don't think so, but we'd be happy to talk about specifics offline and talk a little bit more objectively to see if there is a fit.
Thank you, Vidya. No more questions in the session. Thank you, everybody, for attending. Thank you, Vidya, for the wonderful presentation. Hope you all enjoyed this session. And if you have any questions at all that you did not cover today, or you feel are unanswered, or you have any questions after digesting the material that you had seen today, please do reach out to Vidya at the email address that he has mentioned. Once again, thank you for taking the time out to join, and we look forward to connecting with you again. Thank you.
Thank you. Good day.